Hypothalamus, artificial intelligence. Digital transformation powered by real-time autonomous and intelligent algorithms. Presents its solutions for integrated regional planning, incorporating economy, logistics, infrastructure, and land use. Sustainable development is our common future. The notion of the commitment that each generation has to its successors is at the heart of the concept of sustainable development, which was embodied by the World Commission on Environment and Development, Brundtland Commission, was 1987, in its report Our Common Future, which states that sustainable development meets the needs of the present generation without compromising the ability of future generations to meet their own needs. This can only be achieved with the rational, scientific, use of natural resources, renewable and non-renewable, whose optimal and effective management is the responsibility of the rulers and all their advisors. Cities and regions. Analytics, smart and sustainable. HAI-RPO, regional planning optimization, is a set of mathematical models to support planning regions formed by urban and rural areas with a high degree of integration. The model's mathematical programming are oriented to. The central model of HAI-RPO is presented in the A mathematical programming model for regional planning incorporating economics, logistics, infrastructure and land use. The Chapter 1 of the book. Networks Design and Optimization for Smart Cities. The artificial hypothalamus is the evolution of DSS under the Industry 4.0 revolution, and it is the integration of the methodologies of artificial intelligence and mathematical programming with the modeling of physical systems associated with autonomous and real-time optimization models, which communicate with each other. These system includes inhabitants, facilities, energy, land use, enterprises and industries, and transport and logistics. Integrated region planning. Regional modeling is a planning tool based on a system of mathematical programming models of different types: optimization, econometrics, computable equilibrium, integrated in order to determine the business structure and population development that would exist if certain socio-economic development goals are met. Hierarchical system for decision making is the first step in the definition of a regional planning artificial hypothalamus, its structuring in two ways. Time, related to the transcendence of decisions. Normally 3 levels of planning are used: strategy, tactical and operational. And space, related to the coverage of decisions in space. This structure does not have a defined axis and therefore depends on a frame of reference specific to each region. It is closely linked to the planning instruments defined in the land use plan. The models included in the system are land use urban planning. It determines the spatial relationship between the inhabitants, companies, social systems, equipment, and transportation systems, so scientifically that project what the future development of the urban's regions. Land use urban and rural planning. It integrates land use urban planning with FOSSum, forest and agricultural sector optimization modeling, in a nonlinear programming dynamic model, for integrated planning of urban and rural regions. And regional economic computable equilibrium. It models urban and or rural regional economies, based on concepts of computable general equilibrium, through the simulation of techno-economic input-output systems. Social infrastructure development master plans are aimed at determining the way in which supply should be organized, to meet the demand in the different equipment. Demand is associated with population, which is usually scattered in space according to the places where it lives, works or simply is. For purposes of its spatial location, the demand is associated with an area, in which the demanding population is located. This space must be associated with a point position in the geography, which normally coincides with the centroid of that space. The centroid can be calculated considering the spatial distribution of the population in the area, or simply considering the shape of the space. Supply is associated with small spaces, not comparable in size with the spaces where demand is spread. The supply points are associated with a point in space, so that the problem is reduced to establishing a connectivity tree between the service supply points and the centroids of the demand zones. Mathematical models are available for the following master plans. Equipment of great impact, ports, airports, academic facilities, schools, universities, health facilities, hospitals, emergency centers, solid waste treatment, public space, commercial and/or social centers, and special facilities, social development centers, libraries. Food Supply Chain Master Plan. Regional food supply planning is based in models that simulate the supply chain of food to cities based on the optimization, design and operation, of the logistics chain that is required for this purpose. The objective of the model is to guarantee the principle of food security to ensure the availability and quality of food, reduce the prices of supply, facilitate the access of all citizens to a more adequate food, and build a supply system that revolves around a basket that in nutritional terms allows an adequate diet of the population. The logistics chain includes food collection at the sources, producing municipalities and farms, transportation of food to distribution center, and cross-docking of food towards other distribution centers in the region, food producing companies in the region, and other regions. 4. Food Supply and Public Institutions Master Plan. The optimization models are aimed at meeting the food supply commitments that government entities have in different public institutions, such as colleges, soup kitchen, hospital, and disaster response. Public health systems optimization. Mathematical algorithms for epidemic management, based on high-complexity mathematical methodologies will prevent the most deaths. Public health management implies challenge, to design and implement a DSS to pandemic management. Solution, design and implementation of a DSS aimed at pandemic management integrated by the following high-complexity models. Epidemic Simulation Model. It simulates the spread of the epidemic as a result of a mix of control policies to deal with the epidemic, mitigation, confinement, and vaccination. Modeling divides the territory into regions, the population into socio-economic segments, and time in seasons, in order to have a dynamic epidemiological model including multi-infected states, multi-region mobility, and multi-socio-demographic segment. Epidemic Management Optimization Model. It optimizes control policies, the use of health supply chain, HSC, resources, the optimal expansion of HSC vital components, bearing reference to the Epidemic Control Policy Optimization Model, and the vaccination processes. Epidemic Socioeconomics Impact Model. It determines the socioeconomic impact of pandemic control policies on the economy. Integrated with our S/OPT, it can produce dynamic pandemic control strategies that balance those contradictory objectives that may arise in the epidemic management process, minimize human deaths and maintain the economic's health. And Epidemic State Estimation Model. Hybrid Predictive Analytics Model, based on the distributed Kalman filter, to track the pandemic. Pandemic Management Optimization Process implies research in the following areas: epidemic theory, smart sampling, identification of epidemic model parameters and the epidemic state, and mathematical programming optimization models oriented to control and management of the pandemic process. HAI Health integrates with HAI-RPO, regional planning optimization. This implies that all models of the two systems can be integrated through the database, common data model, or by means of equations that integrate a unique holistic model, this following the principles of structured mathematical modeling. This integration is since the management of public health problem corresponds to regional planning problem, as experienced during the COVID-19 pandemic. Water Resources Systems Optimization. It is a comprehensive system of water resource planning, oriented to the optimal regional planning, in all aspects related to the intensive use of water resource. The model addresses the multiple uses provided and/or for the control and resource management. HAI Water corresponds to a general model that includes all kinds of hydraulic components, reservoirs, hydroelectric power plants, pumping stations, pumping storage, rivers, overflow channels, connection points, and water demands, for irrigation, aqueducts, environmental, industrial, and others. Components can be freely linked to form any topology. Homeland Security Optimization. It is a concerted effort to prevent terrorist attacks within a country or a region, to reduce vulnerability to terrorism and crime, and minimize the damage and recover from attacks that do occur. The main Homeland Security applications based on Operation Research are: allocation problems, police patrolling for subway and bus systems, other scarce resources including bomb-sniffing canines, vehicles, and security cameras, randomized baggage or people screening, allocates air marshals to flights originating in and departing from the country, allocates patrols at ports to minimize the risk of terrorism and drug trafficking, protecting forests from extractors, and cameras allocation to reduce security cost at metro and public transport. Scheduling problems. Scheduling for the Federal Air Marshal Service on commercial flights, and scheduling for police patrols and other police vehicles. And others problems. Evacuations plans, passenger classifications, and vehicle routing of dangerous materials, or people, that minimize the danger of humanity. Disaster and emergency management implies the challenge. Develop a DSS for disaster and emergency management. The overall objective is to minimize potential negative economic impact and human life losses. The solution. Design a set of mathematical models to address the problems arising from disaster management based on stochastic programming models. The benefit. A set of measures and mathematical models to prevent and/or reduce the impact of disasters, and it prepares the community to respond in the best way when a disaster strikes. Actions before mitigation, set of measures to prevent or reduce the impact of disasters. Preparedness, preparing the community to best respond when disaster strikes. Actions after reaction, the use of resources and emergency procedures to preserve the life, property and environment of the community, since the disaster is occurring. Recovery, set of long-term actions to stabilize the community and return to normalcy. The mitigation and preparation of disasters caused by nature implies the overall objective is to minimize the potential economic and human loss, and continuity of operation of the economic system. To this end, the historical behavior of nature is studied, trying to know probabilistically what can happen in order to make decisions of where, when and how to allocate resources to mitigate or prepare for the disaster. For disasters caused by the humans it implies the overall objective is to minimize the potential economic and human loss, and the social impact of the terrorist attack. To do this, models are proposed that study the opponent and hypothesize the decisions that can be made, using game theory models, on where, when and how to allocate defense resources. The reaction and recovery after the disaster occurs implies actions during the disaster, and reconstruction actions. Educational systems optimization. As part of the services offered are timetables for educational activities. It includes allocation of resources, teachers, classrooms, timetables for course exams, medium-term resource planning, student collection/distribution routing, assignment of students to educational institutions, location and capacity sizing of facilities, and food supply optimization. The mathematical models can be customized for special business rules of educational institutions. Management of complex public projects. Public project management is a computable platform to support public management for the planning department of large cities, based on a computable general equilibrium framework, to simulate the evolution of the economy of the city, and its area of influence as a result of the execution of investment plan projects. Planning and scheduling of large projects. Based on mathematical programming models that optimize the execution of large projects, through the optimal allocation of project resources. Investment plan portfolio optimization. Optimization of decisions for the selection of investment, or business, plans based on a mixed binary programming model that contains the constraints associated with the logic of project selection processes, that must respect constraints of different types, which can be social, economic, technical and/or government policy. The model must be stochastic optimization, in such a way as to make decisions that contemplate probable economic development scenarios, selecting a portfolio of business plans that, in terms of expected value and risk coverage, are the best according to the decision criteria of the organization. The objective is to determine the investment plan that allows balancing multiple objectives, such as maximize incremental sales, maximize the jobs generated, maximizing private investment, or minimizing extreme poverty. Smart grids in smart cities. Smart grid artificial hypothalamus is integrated by forecast and optimization models, oriented to support the decision-making of electricity agent smart grids, optimization of the economic and technical aspects related to the smart grids and electricity companies. Buildings and homes demand response, optimization of the management of energy in building assemblies, as universities, malls, office buildings, homes, urbanizations and/or small towns, and industrial energy efficiency, optimization of the energy management in heavy industries intensive in the consumption of energy. Management of electric vehicles. It corresponds to the planning of the management of electric vehicles that is a major problem, given the changes implied by the introduction of this new technology. HAI-L and HAI-SGO are integrated in high power that integrate input-output data models around a common data model. It permits to connect models automatically through the database. Traffic real-time distributed optimization is a research and development area of HAI. Traffic real-time distributed optimization. Optimizing traffic light sync in a traffic system is a complex problem that joins complex areas with complex traffic networks. Solving the integrated problem, as a single problem, may be impossible. Splitting the problem by zones makes it easy to solve the total problem and connectivity, based on principles of mathematical optimization, between the different problems, zones, ensures that the system walks the optimality path. Today's information capture intensive systems, smart metering, allow optimal operating conditions to change dynamically, as traffic behavior changes in the city. The challenge is: develop an artificial hypothalamus-based and distributed optimization algorithms that can handle the computational complexity of the problem and find near-optimal solutions in real time. The distributed optimization decomposes the network-level problem into several standalone intersection-level subproblems and solves them in parallel. The decomposition is achieved by identifying the constraints that represent interrelationships between subproblems and relaxing them. This method is incorporated in traffic model predictive control to account the dynamic nature of the problem and further reduce the computational complexity. Why models based on artificial intelligence? Standardized and easily socializable formulations. Advanced analytics mathematical programming models are not black boxes. Detailed results can be tracked, understood and audited, and systematic analysis of results is much better and faster than intuition and experience-based assumptions. Land use is complex and globally connected. Accurate accounting of available resources. High precision and long simulation period. Models based on macroeconomic behavior. Detailed models based on scientific reasoning. Little influence of intuition on results. Little influence of modeler expectations on outcomes. Better data availability. They discover unforeseen behaviors that are difficult to guess, and increased likelihood of discovering errors. Hypothalamus artificial intelligence. The creator of the artificial hypothalamus technologies. Thank you for your attention.